All right, so there we go. So let's use our calculator though. At this time, you're required to use your calculator. So you take your calculator out and you put an 8.9 plus 31.6, right?
40.5.
Very good. So I want you to work along with me, 40.5, so that just in case I make any error, you can pick up on it. Thank you very much for that. 40.5, I'm going to multiply that. So at the bottom, we have 0.75 times 5.4. What are we looking at?
4.05.
Thank you very much. Thank you very much. 4.05. And then now, finally, you're expected to put all of this on your calculator to get your answer. So put it on your calculator now, 40.5. Thank you very much. All right. Thank you very much. Now, believe it or not, this is a question. So a lot of times people might think it's going to be a very difficult thing. I don't think so. The moment you're attending classes and you're doing the work behind the scene, you are going to realize that, okay, this is all that is required. So that is a simple 1 mark there. So part 2 of A says the value of 3.9 tan 18. One of the first things that you're going to do is to make sure that your calculator is in DEG or D, depending on the calculator that you have. And that's one of the reasons why we say know your calculator, because everybody's calculator is different. You have to know your calculator. The calculator I'm using is a regular Casio, and there's a D on mine. So I'm making sure that there's a D on it because we're working in degree. Look at this little symbol up there. That's for degree. So make sure your calculator is in degree. What you're going to put on your calculator though is 3.9, and you could put multiplication sign if you want, times the tan of 18 degrees. So you put this on your calculator just like that. This question is testing to see if you're able to utilize your calculator, because a lot of people cannot use their calculator. So when you put this on it though, you're going to get this answer, but we're going to have to pay attention to details. We get 1.267186815. All right. I'm not talking using a telephone now. Don't do that. Don't give me a telephone answer. Use your calculator, because sometimes the telephone stop and round off very early. Watch this though. Remember, this is not the answer. All right, because your answer must be conditional to the instruction given. So the instruction had said 1 decimal place. Now, if you send in this, you're not going to get any mark if it is a 1 mark question, and there it is. It's a 1 mark question. CXC does not give half mark. You will get 0 if you send in this, because the instruction is 1 decimal place. Therefore, we're expecting you to round off. So let me highlight what it is that we're going to be rounding off. All right, let me round it off for everybody. So we're highlighting number 2. That number 2 is in the first decimal place. So we're talking about 1 decimal place. Number 2 is in it. And normally, as soon as you have done that and when you identify the digit that is occupying the spot, then you look immediately to the right. And we're looking at a 6. Here is the principle again. Numbers from 0 to 4. If when you look to the immediate right, and immediate right means the next number to the right. If the number falls in the 0 to 4 category, meaning the number to the right is a 0, a 1, a 2, a 3, or a 4, you leave the spot, right? Which means that you round down, because the other things will disappear. Everything that comes after would have disappeared. All right, so you would have left the spot as is. However, if the number right behind it is between 5 to 9, that means a 5, a 6, a 7, a 8, or a 9, the spot goes up by 1. In this case, we'll get 1.3. Exactly. Thank you very much for that confirmation. All right, so you're expected to do that to collect 2 marks. And you have your 2 marks and you're gone already. Let's go to the other part of the paper. We're still on the same question 1, and we're at the B part now. So this is 1B. Right, let me bring it up a little bit more. All right, so this is what it says. It says, so this is about REA. It says REA is paid, and I'm going to highlight some things as we go. It says REA is paid at a rate of $13.50 per hour. This is very important to whatever we're going to do. $13.50 per hour during a certain week. During a certain week, she worked 40 hours. All right. So during a certain week, she worked 40 hours. So the thing is, how much did she earn that week? Now, definitely, if we're talking about money that she earned, we're talking about her wage, right? All right, or pay, whatever you want to say. So your wage is like this. Your wage is, let me move it from that because there is a thing on my screen. I don't know, it's not coming out. So your wage is going to simply be the rate that you're working, and they call it the basic. They call it the basic rate. Let me write it. Your basic rate, which is your normal rate, times your basic hours, right? Your basic hours, or sometimes it's called your basic week, depending, because week is time. And so it's hours, all right? So your basic wage, so everything is basic. And this suggests that this is what you would have made ordinarily. So that is very important, because when you start to put in more work, then it's not basic anymore. It would be overtime and a lot of things mixing up. So this one is the normal thing. So she's paid $13.50, and she actually worked for 40 hours. So you could see this is a normal thing. Imagine that you were called to work and you were paid $13.50 an hour and you work for 40 hours. Definitely, you will know exactly how much money you will be getting. And Rhea would have gotten $540 for that week. Is that clear?
Yes,
Is that
sir.
clear? All right, very good, very good. And remember again, these are CXC questions. I didn't make them up. All right, so you should use this to kind of boost your confidence as you go along. All right, there is a follow-up, and there is always follow-up questions to these. It says, Rhea worked 4 weeks, right? Rhea works 4 weeks. All right, so you know that 4 weeks. Remember, I know. Let's go back here. You know that this is for 1 week. All right, if you check it out, it says during a certain week, and a means singular, 1 week. All right, coming back up here, Rhea works 4 weeks. All right, and then when she worked, I don't know. Hold on, give it a second. Something is clicking here. All right, good. We should be okay now. So it says Rhea worked 4 weeks in a certain month. All right, of August. So we're talking about the month of August, and her gross earning was all of this. Listen here, her gross earning. That means when everything comes together. So we're going to see the different things that happened that particular month of August, right? Her regular week comprised of 40 hours. So this is regular, as we said before, basic, all right? And overtime. So now there is an idea concerning overtime. It is saying that overtime is paid at time and a half, right? Her hourly rate. So we're going to talk about that idea of overtime, right? Now, show that Rhea worked 15 hours on overtime. We're going to go to this in the end. So this is the last thing we want to prove. What we want to understand is, what is this question saying? All this question is saying is that Rhea worked her normal money, because she worked her normal 40 hours, and then she did more time. So she did more time than 40 hours. She did that. She went over and she worked some overtime hours to make some more money. Now, on overtime, she's not paid $13.50 per hour. She is paid what is called time and a half, her regular rate. So now what we want to do is that there are a lot of things we can do. We can work out some stuff and put it down. If you're going to work out anything as it relates to overtime, you definitely going to need to know the overtime hours, all right? Not the overtime hours right now, but the overtime rate that she is paid at, all right? So we can work out all of that. Another thing also is that we're going to work out a regular week and then see how much money she made on overtime. Now, watch this. Now, let's start here. 1 week. So for 1 single week, she would have earned $540. We know that much. This question said that she worked for 4 weeks. So now we're talking about a regular thing, you know. 4 weeks, you're expecting her to collect $540 times 4. So you could see that coming out, all right? $540 times 4. So for the 4 weeks that she worked, you would have expected 2,160. But then you're saying, but no, she didn't carry home that. She carried home more. So then you would have realized that, oh, it's because she did some extra time in that month. That's what we're talking now. So we were expecting her to take home 2,160, but she did not because she worked some overtime. So what you want to do now is to split our regular money from the gross money. So look at this idea. I'm writing some formulas. I'm not rushing anything. I want you to see and understand how to approach these questions. So I'm taking it the long way. Basically, what I'm saying is this: her gross salary. And when we talk about gross, we're talking about when everything comes together. So her gross salary would be her basic wage. And when we say basic wage, we're talking about the regular thing that she would have made, plus her overtime wage. So this would constitute this gross wage when you work regular, plus now you put together the overtime, when all of that come together. So what we're saying here, if you really look, let us do a quick substitution because I'm not rushing. We're talking about the gross was 24, see it up there, 24.63 and 75 cents. That's what she would have made overall. Her basic money for that time is 2,160. So you can see, that it's only the overtime, and I'm going to use OT for overtime. Bear with me, OT. I'm referring to overtime there. So what we're saying is, look at this now. I am able to see the overtime money if I do some little mathematical calculation, right? So I could just simply subtract 2,160 from both sides. So watch me. So hold on. Let me fix this. We're talking about $2,463.75. And then you're going to subtract from both sides 2,160. I'm just going to write this so that you can appreciate the truth. All right. That's the truth to what happened. All right. So I'm not in any rush. I'm just showing you what really happened. So I'm not going to tell you that anything go across and the sign change. All right. So we subtracted 2160 from the right side. You subtract it from the left side. Could somebody tell me the value that you will get?
$303.75.
All right. All right. You said 350?
303.
All right, hold on. I'm not hearing. Sometimes when you talk.
303.75.
Okay. Hold on. Did you say 303?
Yes, sir.
Yes, sir.
All right, all right. Who is that? Chad? That sound like Chad?
Sir, Wooly Howie, sir.
All right, very good, very good. So 303.75. And this is what? Look on the right side. This is overtime wage or overtime money. Now we have gone into the overtime section where it's only overtime things can work for overtime. Now, in order to prove that she worked 15 hours on overtime, all I need to do is to see how much she is paid on overtime, and that is called overtime rate. Now, if you go back up, so let us look at the question itself. It says here that the overtime rate, there is an agreement that she will be paid time and a half. Time and a half means you're going to multiply her regular wage, not wage, rate by 1.5. And that is where you get the time and a half. 1.5 is time and a half. So let us put this together here. Now let me write. I'm going to just write here what I want us to focus on. Overtime rate. I don't want to write too much now. So it's going to be 1.5 times her basic rate. And this is going to tell us how much money she's working on overtime. And this is what you use to calculate the math. So on overtime, she's not working $13.50. No, she's working $20.25. This is her overtime rate. Can everybody see the rate that she's working on overtime? All right. All right, good. So in order to find, yes, go ahead, I'm listening. Sounds like there's a question.
The 13.50.
13.50.
Yes. Thank you. How did that happen?
We got it in the, up top, we got it. We got it from them that's the rate she's paid on a normal basis. Let me show you.
Oh, okay.
All right, all right. So it makes sense now, because remember the question is the follow-up. Let me show you. It's a follow-up, See it there? So you see it up here, so it's a follow-up And that is how the questions are. All right. Nothing is basically isolated. It's a follow-up. So you have to remember you jog, go back up, look, and then come back. So we're saying the overtime hours that they ask us to prove, we should get it now if we divide the 303.75 by 20.25. If you do this, you should prove that it is 15. Divide that for me.
15.
Exactly. And that's what the question had asked, that we need to prove that she worked 15 hours on overtime. So I'm saying, you know, it's not a rush thing. You have to take your time and develop the thing, and it goes to the end. So that's the question right here, where you were supposed to show that Rhea worked 15 hours overtime in August. And there it is, we have proven that. Good? All right, I'm recording the session here because you will get it later to watch for a while. I'm not sure how long they can keep it before it's deleted, but at least you could rewatch. All right, let's go, let's continue. In August, watch this now. In August, 20% of Rhea's gross, pay attention to details, gross, right? So 20% of Rhea's gross was deducted as tax, 20%. And when we talk about deducted, we're talking about remove, taken out. The question went further to say, how much money does she have left after the deduction? There are two approaches to a question like this, and I might just do it the two ways for you. One approach is that we need to find 20% of her gross. And I think her gross was, let me write the word off. It was 2463. Confirm for me. 2463.75. Am I correct?
Yes, sir.
All right. So we can find 20% of this and take it out of it. Remember, you know, finding 20% will not be the answer because that will be the deduction, but you need to deduct it. That's one way. Or if you don't want to work it that way, if you understand that 20% will be coming out, it means that she has 80% left. So there are two ways we can approach the question. All right, so we're going to look at it and see what we get. So let's go about finding 20% and then take it from it. So let's go. 20 over 100 stands for 20%. Multiply by 2,463.75. Somebody work that for me. Put that on your calculator.
492.75.
Talk to me. What you get?
492.75.
Thank you very much. So we get 492.75. Then the final thing now is to say, guess what? We're going to subtract this. We will subtract this from that, the gross. Tell me what you get now. All right, let me assist you as well. I'm getting 1,971. Yes, $1,971. So that's one way how you could work, because this 20% that we have here is the deduction. So we took it out, and whatever is left, that's the answer. Now, as I said to you, there is another approach. So we are trying to appreciate ways in getting our answers out if we really understand percentage. So this is 80%. That's what this means, because 20% came out. That means we can say 80%, 80% of 2463.75. If we find 80% of this, we'll definitely get the answer one time. So it's all about your appreciation for numbers and what you love. You will definitely get the answer, maybe a little bit faster, but guess what? It's what you understand. All right, guys? So here it is that we could have gotten the answer this way as well. But in an exam, you only need to show one way, but because we're in the learning process, we're doing two things now because I feel like I want to do it. I'm not always going to do all the options, all right? But I just wanted to. All right, is this clear? Everybody see what's going on there, and that's fine?
Yes, sir.
All right, good. All right, good. All right, let's go. Let's see what's going on. All right, I'm turning on a fan on myself. If it's affecting your sound, you tell me. All right. If you feel like it's affecting the sound, I'll just not use it, but I feel hot. All right, so let me know if the sound is affected. All right, let's go. Ria, no, the last part of this question. All right, well, I'm not even sure if this is the last part. Maybe, yes, it seems so. It's the last part. So the last part of this question says Ria invested. So here it is. Ria invested $219. All right, of her earnings for 3 years at a rate at 4.5% per annum, simple interest. We are told, all right, simple interest. How much interest does she receive after 3 years? Remember, there's a formula for simple interest. Simple interest says that to find the simple interest, it's the principal times the rate times the time all over 100. I'm not going to give you 3 or 4 formulas. I'm just going to say, cherish this formula now, and then substitute at the appropriate places. All right. So again, there are other ways to do it, but I'm just taking this route. So I intend to substitute. You understand? I intend to substitute at the appropriate places. What do I mean? Now, what do we have? Right? All right. So these things here, that's the time right there. This is the rate right there. Invested, this is P. The principal is the money invested. All right. So the question says how much interest. So our intention is to find the interest. So it's going to be P, which is 219, times R, which is 4.5, times T, which is 3. And all of this must be over 100. Now, make sure that your calculation is proper. All right. So let's go. 219 times 4.5 times 3. All right. Times 3. Well, normally I just write it. So let me write this before I write the final answer. That's just me. All right. So I'm writing what's at the top. All right. Make sure that I'm not making any error, guys. Double check. Divide by 100. So when this is divided by 100, you know that the decimal, divide it by 100 if you want, but because it's 100, I'm just going to do this. If you have a calculator, go ahead and do it. So we're talking about 29.565. I want you to understand though, money has a default decimal place. Anybody want to quickly remind me when we're dealing with money, how many decimal places that we're expected to be rounding off like a default?
2.
Thank you very much. 2 decimal places. So then we're going to identify the digit that is in that second spot, and it is a 6. And when we look to the right of it, we have a 5. That means this spot will go up by 1. So the right answer is $29.57, not 56, because we had to round off. Everybody see that? So that's the interest. Straightforward. Yes, go ahead, listening.
Sir, what if I got 0.29565?
0.29565. What if you got this?
Yes, sir, that's what I got.
I need you to clear your calculator and do it over. I'm not sure how you got that. So clear your calculator. You clear it?
Yes, sir.
You're gonna put 2,956.5 divided by 100. Clear it and put it.
Oh, okay.
You got it?
Yes.
All right. All right, very good, sir.
I found out the problem.
All right, good. All right, so that is number 1 fully completed, and we're talking and so on forth and blah blah blah. But definitely for every question in CXC, you have 16 minutes to finish the question from top to bottom. All right, exam is 2 hours and 40 minutes. That's like 160 minutes, and you have 10 questions, so it's like 16 minutes a question. All right, and I think you can do that, because we really took about 16 minutes to do this, but we're talking and doing this and blah, blah, blah. But when you're in the exam and you're flowing, you will take probably less than 16 minutes to do it. So that's question January 2022. Let's go for another year. I'm not sure of the years that I have here because I cropped them off. So I don't know what to say to you, which year it was. All right, right now. All right. Let's go. All right, again, we're at number 1, and what I want you guys to do is to, while I work, start looking to see patterns in terms of what it is really come at number one. That's what we're doing right now. What really comes at number one? You're gonna see over and over what comes at. When I say number one, Chad, I'm talking all of number one. Like what we just completed just now, all of that was a number one. So we're at 1A. All right, so this is what comes at 1A right now. All right, so let us just go about and do this. So we have 1 and 4/7 divided by 2/3 minus 1 and 5/7. All right, what we're going to do is just to convert all our mixed numbers to improper fraction. All right, so we're just going to do the conversion quickly. Remember, the conversion is that you multiply the denominator by the whole number and then you add the numerator, and everything must be over your denominator. So we're talking about 7 times 1, 7 plus 4. This is 11/7, right? Divide by 2/3, and we're going to subtract 717 plus 1, that is plus 5, it's going to give us 12/7. All right, so we have this to do. Remember though that we're going to see what goes on right here. All right, so let's work out this part first. So 11/7, when you divide, you change your division to multiplication, and you're going to reciprocate or flip upside down the fraction that comes immediately right there. So we're going to turn this from 2/3 to 3/2. All right, so you could see that we reciprocate that right there. After doing that, if there's anything that can be canceled, you do it. If not, you multiply the top by the top, and it's going to be over the bottom by the bottom. So everybody could see what we're about right now. So we're talking about 11 times 3, that's 33, over 2 times 7, 14. That's what we have right now. And what are we supposed to do now? We're supposed to subtract. So I'm going to write it now. We want to subtract 12/7. Remember though, that when you're subtracting, right? If you have different denominators, even when you're adding or subtracting different denominators, then we need an LCM to propel us forward. All right, so in this case, we have a 14, we have a 7, 2 different denominators. We need what is called the LCM. Yeah. What number can the 14 go into and the 7 go into without leaving a remainder? What's the lowest number that suits that? Can a 7, can 14 go into 14, because 7 can't work, because remember, if 14 goes into 7, you know what I mean, we're not going to get that whole number coming out. All right, so let us go now. What we're saying now is 14 into 14 is 1 time. So 1 times 33, that gives us 33. 7 into 14, that's 2 times. And 2 times 12, we have a minus 24. All right, we're almost at the end. So we're talking about 33 minus 24, and we get 9. So this is, the response is 9/14 for our final answer. And you collect your 2 marks right there. Clear?
I can't change the box, sir.
Look at it carefully. Look at it carefully. Isn't that a proper fraction?
Yes, it is.
So what is there to change? Nothing. And let me tell you something. Even if it was improper, don't waste your time to change it. You don't get any marks to do that. Matter of fact, on every one of the reviews that I see, they leave the improper fraction. They don't even waste time to put it back to mixed numbers. All right, guys? So remember, an improper fraction is proper, meaning it's good to go. You don't need to be worrying that you have to put it back into no. Understand? You're good to go. You get your full marks, that is. All right, let's see what's going on for this. It says Megan, let me change the pen. It says Megan, when Megan started working, she was paid $85 each week. I have to pay attention to details. So $85 each week. After a 6-month probationary period, her pay was increased by 20%. So that means her pay went up from $85, right, per week. How much was she paid each week after the increase? Right. Matter of fact, there are two ways to do this again. I don't know if I want to do it two ways again. There are a number of ways to do it, about 3 ways. I'm just going to select one. All right, guys? All right, so let us say, I'm going to do it the standard way everybody loves. Whenever you have the original thing in your hands, right? When you have the original thing in your hands, you can play with it. Ways in which you can't play with other things when you don't have the original. Meaning, Megan started working. When she started working, she was paid $85. So this is her original salary. So you can manipulate it. So 20% of this, all right, was what the increase was. But you're going to have to add it to it so that you could see the new thing that she is getting. So this that we're trying to do is to work out the monetary increase, 20% of 85, and this looks like about 17. But we're going to work it out. So it's 20 over 100 times 85 over 1. Definitely this is 17. All right. So this is $17. But this is not her new pay. This is just what was added. All right. How much was she paid after? So if you want to know how much she was paid after, you're going to have to take that 85 and add it to the 17. And whatever you get there would be your answer. We're talking about $102. She's now paid $102 per week. Anybody? Any question? Is it straightforward, understandable? We're seeing where we're putting things together and then going there at the end of the day. Anybody wants to comment? Say anything? Good to go?
So, sir.
Speak, I'm listening.
Say you left off the dollar sign.
Okay, all right. If you notice, I put it in the end, right? Right here.
Yes, sir. No, me I say, what if you leave it off?
Oh, I really can't tell you. I really can't tell you, depending on the objective that they have. They mark with objective. I can't really tell you, but don't leave it off. Don't plan to leave it off. That's all I can say. Don't plan to leave it off. Depending on the objective that CXC has for the question, honestly. But
Okay.
definitely 100. But why? I don't want to tell you that, oh, you're okay. Why would you want to plan to leave it off? The exam is not yet. So don't leave it off, because I didn't leave it off. And notice I put it. So don't leave it off. All right. All right, let's go for the, oh, there's another question. All right. All right, so this is the C part now, all right? All right, so here's the C part to the question. So I think I remember what this question is. I think this is the 2021 here. This is the 2021 May. Let's go. It says in 1965, the population of country A. If you notice, I like to underline my stuff and highlight. The population of country A was 2,714,000. In 2015, the population was 3,663,900. So we are seeing that there is an increase in the population. You can see that. It went up. Population went up, right? Now, write the population in 2015 correct to 3 significant figures. You see that? 3 significant figures. So let us take it out and look at it. 3, 6, 6, 3, 9, 0, 0. Now we want to look at that. We're talking about 3 significant figures. Remember that all digits are significant except zeros, which may or may not be significant. We have to remember that, right? Now, 3 significant figures. All digits are significant except 0. And remember, the first significant figure is the first non-zero digit moving from a left to a right. All right? The first significant figure is the first non-zero. That means 0 will never be the first significant figure. Can never happen. All right? So just remember those little stuff. I'm just working the question though, and as I go. So the first significant figure would be the 3. The second would be the 6. The third would be the other 6. So this is the third significant figure, that 6, not the one before, that one. And let me point at it for you. This is the one I'm talking. Now, when you identify a digit that is in that spot, you're going to have to do the same rounding off principle. We're going to focus now on the digit to the immediate right, and immediate refers to right beside it. That's a 3. And 3 is in the 0 to 4 category. That means the spot will remain. Now, what spot? This 6. Let's write back 3, 6, 6. We'll have back that. But remember now, you know, guys, we're talking about 3,663,000, you understand, 1,900. So you can't round off and say this is the answer and gone, because there is no way you round off 3 million and something and the answer is 300 and odd. So in this case, you need a placeholder for each digit to give back value to the question. So we're giving back value. We need to replace these with zeros. I am not telling you that you replace with zeros every time. You only replace with zeros when you're giving value. Hopefully we'll see a question that comes up where there is no value, all right? Being added. But everybody, we're good with this? 3 significant figures?
Sure, so you run it up to the nearest tens.
No, we didn't run it up to the nearest 10. We rolled it up to 3 significant figures. Significant figures, I just said it, we count from left to right, the first non-zero. This is the first significant figure. This is the second significant figure. This is the third. This is the fourth. This is the fifth. These are not significant. Zeros at the back are not significant. Zeros at the front are not significant. Zeros that fall between are significant. But I'm just saying, this is just a question I'm doing. I'm not really teaching significant figures to go into the details, especially when a decimal point comes in and so forth. All right. I don't want to crowd up what we're doing. But definitely the third significant figure was 6. And when you look to the right, there was a 3. All right.
Again.
A mic is open and I'm hearing you. Mic is open, I'm hearing you.
I can't rotate my phone. I don't know if
All
it
right.
do it.
All right. Colleen, Manta.
That's a quick share.
Colleen, Manta.
Rotation.
All right, let me just close this. All right, good. All right, good. All right, let's go up again, everybody. All right. Write the population. Here's the thing now. It says, write the population in 1965 in standard form. Remember the concept of standard form. So 1965. So we're going to write, where is it? Where is, oh, 2714 with some zeros. All right, let me write it. This is, I'm writing what we need. So this is 2714 and some zeros. So this, let me make sure it's the same thing. I don't want to make any error. 22714, yeah. They're asking us to write this in standard form. There's a principle about standard form. So let us just quickly look at what is standard form. Standard form is such that it is written in the form A times 10 raised to the n. And when we say to the n, we're just talking about numbers now. But watch this. A is a number. A is a number that will be less than 10, and it will be greater than or equal to 1. That's what A is. So what this is saying is that you will have 1 point something, 2 point something, 3 point something, 4 point something, 5 point something, 6 point, 7, 8, 9 point something. You will not have 10 point something, never. And you will never have a 0 point something, never, when you're dealing with standard form. It's the 1 point something all the way up to 9 point something every time. So there is a signature or there is a framework for standard form, and you will say times 10, not times 1,000, not times 1,000,000. It is always times 10 raised to a number, and this number is an integer, meaning there is no decimal up there, there is no fraction up there. It's going to be negative, positive whole numbers. All right. So the negative of the whole numbers themselves. And you know zero is involved, right? So basically now we have this to put in standard form. I want to say to us that whenever, remember, it's decimal point now. In standard form, the decimal point must come after the first digit that is not a 0. In other words, the decimal point must come after number 2 in this case. Where it's going to go? Well, it's going to land right here. Oh, but where is it coming from? If you do not see a decimal point in a figure, it is at the extreme right of the figure. All right. And that is why we don't write it, because there is no number that comes after it. We leave it off. So it's going to be moved from there. So you could, let's write the framework of what we're about to do. You're going to be writing 2.714 times 10. This is like the framework. And because these are zeros, I don't need to write them back. But if you write 0, 0, 0, you're fine right now, because we're not doing significant figures. We're doing standard form. So we have 2.714 times 10. And then now we need to check to see what power of 10. All right, so we're going to jump. Each time we jump, it's a power of 10. So it's 1, 2, 3, 4, 5. We actually jump 6 places to land here. So it's to the power of 6. Now, I want to say to you that while it being the power of 6, everybody double check it so that I don't make any error. This 6 could be negative, it could be positive. But there's one thing I would say. Some people say if you move the decimal point to the left, it's positive. I say to people, if the original thing that you have to change is bigger than 1, then it's always positive. And as you could see, yes, this number is bigger than 1. So this is a positive. All right. All right. So 2.714 times 10 raised to the 6th power. And you notice I am spending so long to talk to you. You say how much marks for it? 1 mark. Because a student in the exam who knows it, just write it on gone. So it would take them like 2 seconds to write it because they know exactly what they're doing. So it's not like they're trying to explain or wonder. Understand? So it's just a quick thing that you can write. All right, let's go further. Now, the question went further and it says, determine the percentage increase. So you could see now the jogging on your conceptual understanding to see how much you really know. It says, determine the percentage increase in the population from 1965 to 2015. The percentage increase. All right, if you're going to write the percentage increase, I'm going to write it in a little short form. The percentage increase, I don't like how that looks. Hold on. Oh, hold on, guys. All right, so the percentage increase, right? This percentage increase that we're referring to. All right, the percentage increase is an idea. So let me just write. Percentage increase, right? It's going to be your increase. That means your literal increase over the original thing. And you're going to multiply this by 100 over 1. And this is when you're turning it into percentage. So what you need to do is go and find the increase, put it over the original, and then you divide by, and then you multiply by 100. So the original, so let us go for the increase. The increase was moved from, let me see what it was, 36. Okay, so it's 3663900. So we're talking about it moved from to this. So this was the final landing for it. It's coming from this. So the smaller one I'm putting at the back. And it has to go over the original. The original. And then you multiply this by 100 and it turns into percentage. So, all right, let me highlight some stuff. This is going to give us the increase that we're talking, this. And then now this number at the bottom here, this is the original thing. All right, that's what we started out with. In 1965, population of our country was 2,714,000. That's what we're talking. So let's go about just work out now. Come on, let's get in some values. Please don't make any mistake with the numbers you're looking on, because if you do, you're in problem. I want people to confirm with me what they have. I get at the top 949,900, and I'm going to put this over 2714,000. All right, and then we multiply that by 100. So now we're just going to go straight through. All right, so
35.
Exactly. Thank you.
35.
Thank you. You are correct. 35% was the increase. That's what I got as well. Very good working out. All right. Accuracy is needed as you go. And I believe that this is that. Let us see if they had anything else for us. If not, we're moving on to another question. All right. Yes, we're moving on to another question. All right, let's focus on this question. So this question says here, the ratio of teachers to male students to female students. All right, so it's a three-part. Let's go again. I read over. The ratio of teachers to male students to female students in a school is 3 to 17 to 18. This is very important. All right, so I'm going to use the highlighter to highlight male, and I'm showing you the male. The ratio of teachers, okay, hold on, let me go back. Teachers came first, hold on. I'm going to show you the teachers. Here's the teachers, and this is for teachers. I'm going to show you, I just itemizing the thing, males. So this is serious, you know. And here's the part that deals with males. I'm putting it in color. I'm color coding this. At least you must understand. All right. And then the last piece of color I'm going to put out there, I'm going to probably put a blue out there. All right, to females. Here is the females. All right. And that female part there is 18. I'm saying if you look at the color code, these are how the proportions were actually allocated. All right. So that's how it's allocated. So here's the deal now. Let's see what they want. When you really understand what's going on, they can't really mess with you. It says if the total number of students, you see this? This is very powerful. They didn't say the total number of persons, the total number of students. And definitely we understand that teachers are not students. So if teachers are not students, this is not in our working right now because they're talking about the number of students. So you're gonna have to pick out what is the number of students. All right, we're dealing with is 630. Determine the number of teachers. All right, no problem. So what we're saying now is that we are going to make some links, and then we will have to appreciate that 17 was for male, 18 was for females. So when you come together, you're talking about 35. When you add these, you get 35. I'm going to write PPT, and I'm referring to proportional parts. We have 35 proportional parts. That's all the number of students here. And they did say it was 330 students. I am saying this is what we're running with, right? Because based on the clues that we have, we can't just add up everything here. No, you can't, because we only got things about students. So we pick off the ratio that deals with students. So my yellow and my blue, all right, is what I'm working with right there. So when we add our yellow and our blue, here it is. This is my, all right. The fact that I mark up that, let me move on, leave that. All right, let's go. So here it is. What we want to do now is just to dissect the idea and then go for what they want. Understanding what is asked is very important. Determine the number of teachers. So at the end of the day, we want to know how many teachers are there. But I do know that the teachers were allotted 3 parts. Therefore, if I can find what one part is, one proportional part is going to be 630 divided by 35. So we want to split up that into 35 equal pieces, right? And then we're going to realize that, oh, one part is 18. One part is 18 people. I'm just saying one part is 18 persons or 18 humans. One part. Now, if they're talking about teachers, and then teachers would have gotten 3 parts. Therefore, it's going to be those 18 times 3. And this looks like about 54. But I love to double check with my calculator. So I multiply this for real and I get 54 teachers. That's what we're talking about. So yes, it's ratio and proportion that we always do. But we have to be very careful as it relates to how we dissect the problem. Please read with understanding as you go forth. Thank you. Any question pertaining to that? 2021 number 1 is finished. See there, 9 marks for it again. So you cannot see that it's a 9-mark question, and they would have A, B, and C. And these are the types of questions coming there. Fractions, consumer maths, and working with your calculators, finding values like tan and cosine straight. They're just a 1 mark, stuff like that. All right, let's move forward. We want to see what's next. All right. Again, this is, I think I did it in order. So this would have been January 2021, I think. Now you could see number 1 comes in a fraction format again, almost like the one we did, but it's not it. All right, so let's change all our, so the principle remains the same. We're going to change all our mixed numbers to improper fractions. So we're talking about 717. We're talking about 717 plus 4. So we're talking about, this is 11 over 7. Is that clear? Everybody agree with that? 11 over 7?
Yes, sir.
All right. Give me 1 second, guys. Somebody is asking me something. All right. Hold on. Sorry about that. Yeah. All right. Almost there. I'm almost there. Just let me just. All right, let's go now. Let's go. All right, so we're saying that we have 11 over 7. I apologize. And this is plus 2 over 3. And we're subtracting 616 plus 5 again. That's 11 over 6. Is that good? Everybody can see that? All right, guys. The thing is, I'm going to say something to you. All right. You see, if you get addition and subtraction, they are operated under the same rules. You can do it one time with one long line. Addition and subtraction, honestly. So you can use one LCM and just work out your math. Let me say it again. For addition and subtraction, you can do them together. It's fine. All right, but don't mix up other things. Let me say it again. Disclaimer, addition and subtraction can go together, as well as some people work out this piece and then work out. But I'm just telling you that addition and subtraction can go together. All right, they are under the same rule. I feel like I want to do it. All right, so I'm going to go with it. All right, so addition and subtraction can be done together. All right, what's the LCM for 7, 6, and 3? You have to know your timetable a little bit. 42. 42 sounds good?
Yes, sir.
All right. So 7 into 42 is 6 times. So we're going to say 6. Hold on, let me put the 6 closer. So we're going to say 6 times 11, and that is 66. Right? And then now, 3 into 42 is 14 times. 14 times 2, that's 28. Then 6 into the 42 is 7 times. 7 times 11, that's 77. There it is. So let's put together those numbers. Remember, you're in an exam that uses calculator. Please put the numbers on your calculator. All right, so that's 94 minus 77. I'm having 17 over 42 right now. Confirm with me, anybody, please. Confirm with me.
Yes, sir.
Everybody got that?
Yes, sir.
Yes, sir.
Very good, very good. So that's the answer, 17 over 42. All right, 17 over 42. All right, so let us move it on, moving on. All right, so now this is what came as well, and then we're gonna look at this. It says, write the value of, let me rewrite this just in case somebody's not seeing it properly. So this is, all right, I heard somebody said it, very good, the cube root. All right. So it's a cube root. In other words, then you want to find the number that multiplied by itself 3 times to get this number. What number multiplied by itself 3 times and this number 27 shows up? That's what you're trying to find, right? I'm not going to tell you to do any mental mathematics. You could put this on your calculator, but then again, you have to know how your calculator operates. So I would suggest to you, find the cube root of 27 on your calculator. I'm not doing a calculator session, no, so I won't be able to say if you have this calculator, do this. I won't do that, but I could tell you that you will get 3. All right.
3, sir.
So thank you very much. You will get 3. So you put this on your calculator, you will get 3. But watch this. Watch this. Now, 9 square is 81. 9 times 9 is 81. But you see, most importantly, they said this. You can't submit this as the answer because they said to its lowest term. So obviously, you're checking. Can 3 go into 81? Of course, 3 can go into 81. Understand? So you will see that 3 into itself 1 time. 3 into 81, 27 times. The answer is 1 over 27. 1 over 27 is the answer. Good to go?
Yes, sir.
Yes, sir.
All right, very good, very good, very good, very good. So we collect those 2 marks. Guys, when you catch number 1, 9 little marks, you're not supposed to get nothing wrong. You notice you're not see nothing yet will really trouble you. All right, it's just that you need to just relax and go. Doesn't matter what the question looks like, just trust yourself. Remember that you have done a lot of things concerning those. All right, it says the thickness. So now this number 1 question has a little reasoning in it, it seems. All right, maybe not this part, maybe the other parts, but let's go. It says the thickness of 1 sheet. Hello, the thickness of 1 sheet of cardboard is given. This is the thickness of 1 sheet, you know. So this is it. This is how thick it is. All right. In other words, this is the breadth of the thing. The thickness of it is 485 times 10 to the negative 2. We'll talk about that, millimeters. It says a construction worker uses 75 sheets. Okay. So, all right, this is the thickness. And there's a worker, a construction worker uses 75 sheets of cardboard. 75 of these, no problem. Stuck together to insulate the wall. All right, no problem. So we have an understanding of what's going on there. We have one thing that is this thick and we use 75 of it when it is that thick. All right, let's see what they want to ask. Show that the exact thickness of the insulation, let me read over. Show that the exact thickness of the insulation is 363.75 milliliter. I don't have a problem. All right. So what you want to do, remember, they want to know the thickness is 75. But let us say that when you see this, you may be wondering, boy, I wonder what this is. I don't have a problem if you're wondering. All right. So if you wonder what this is, the negative here would mean 1 over the idea. It's an inverse, so it means 1 over. So watch this. I'm just doing this for clarity. So 485 times 1 over 10 squared. That's what this means. But everybody know that 10 squared means 100. So basically then you're saying 485 times 1 over 100, which really means that you're dividing by 100. That's what it really means in the end. All right. So I'm just trying to show you what it really is. So if this divided by 100, definitely you're seeing that. Let me write, you know what? Let me write it out. Not plain. So you divide this by 100 based on what this is, and you're going to get 4.85. I'm just saying. So this is, I'm just saying, I'm just explaining. This is the thickness for 1. No, they use 75 of these. So therefore, the insulator, you see that insulator? Thickness. Let's deal with the insulator thickness. It's going to be 4.85 times 75. And the answer must show up. Nothing else is there to do. So let us do this. 4.85 times 75. The answer must show up exactly as they had said. And this is no joke. All right. So just put it on your calculator, put it up and put it together. All right. Here you go. So one of the things I kind of like with these things is You see, when they said show, they're already telling you what the answer is. So in other words, then what if you do this and you didn't get it? That means you made an error somewhere. Just clear your calculator, look back at what you have and just punch in back the numbers. Because they're already telling you that you should get 363.75. Thank you. All right, let's go to the next question right below it. Write the thickness of the insulator correct to two significant figures. So you see now they are moving us forward, the thickness of the insulator. Would you agree that the insulator is everything combined? All of that, all right? See there? Show that the insulator thickness is that. So basically, even if you didn't get this right, you could go back to the question and do this because they gave us this. So we want to show this 363.75 to two significant figures. Again, all digits are significant except 0, which may or may not be significant. I am not seeing any 0 here. So what's my first significant figure? 3. What's my second significant figure? That. Remember, significant figures comes from left to right. So the 3 that I'm referring to was this one first, this one second, this one third. But the thing is, we were not asked for the third, so we go to the second, we stop. So we look. Now, as soon as you have identified the digit that is occupying that spot, look to the immediate right. So when you look to the immediate right, there's a 3, it's in the 0 to 4 category, which means that it's not going to change anything. So we're going to have a 3, 6. Guys, you cannot round off 363 and get 36. It can never happen. All right. All right. Looking at my thing to see if I'm getting some. Hold on, guys. Giving the laptop some breeze underneath. All right, let's go. All right. So let's think again. So now we are going to have to give a placeholder, and then you have to going to be very, very accurate with what you're doing. You put a 0 here to give value. 363 round down to 360 right now. Somebody might be asking, sir, why don't we put 0.00? Somebody might ask. So the question I would ask to you, would these 0.00 give value to 360? Is it increasing? And I bet you're going to say no. All right? No. That means don't put them, because when you introduce a decimal point and you have started counting significant figures already, everything becomes significant. Let me say it again. When a decimal point is in your figure and you have started counting significant figures, then everything becomes significant. For example, this is one significant figure. 2, this is going to be 3, this is going to be 4, 5. You're going to end up with 5 significant figures because a decimal point changes the significance of things. That's just how they had set up the significant figures. And God make it, that's how man make it, and that's how they said it goes. Say this have to work with it. All right. All right. So the answer would be 360. Two significant figures. All right. All right, hold on. Let me see if I can move up this. All right. Moving along. Correct to 1 decimal place. So we're supposed to write that to 1 decimal place as well. 363.75 to 1 decimal place. Identify the digit that is in the first decimal spot. Remember, we are coming from left to right. The first decimal spot is a 7. Thank you for saying that. First decimal spot is a 7. And when you look to the immediate right, there's a 5. So there's a 5 to 9 category man. So that means this spot will go up by 1. Hence, we'll have 363.8. And we're not going to do anything. When you're rounding up to decimal place, you don't have placeholders unless the placeholder is actually responding to the decimal place that you need. Right now, this is 1 decimal place. Do not put any 0, because if you put something around here, it becomes 2 decimal places, meaning 2 digits after the decimal point. So when you're asked to round up to decimal places, you're expected to look at the fact that any number they have here, you need to see that many digits after the decimal point moving in this direction. So we're seeing we're 1, and that's it, 1 decimal place. All right, there it is. Not bad, not bad, not bad, not bad. Go ahead, I'm listening. Is a question?
Well, yes, sir. What if them have 363.95?
Let me write it. You want me to write it and then we talk about it?
Yes,
See it
sir.
here. 363.95. And what's the question?
1 decimal place.
All right. I see you're thinking. Very good. Very good. I like this. Now we're gonna put in the regular. Don't overshoot anything. Just be real. You understand that this is in the spot, right?
Yes, sir.
And then when you look to the immediate right, you have a 5, which means that 5 to 9 category, this spot will go up by 1. Now, if this goes up by 1, you know that we can't write 10 in a spot. So it becomes 0, and you carry that 1 set of 10 to the other column. So this becomes 364.0. See that now?
Yes, sir.
And watch this.
Yes, sir.
Don't be, hold on, let me say something. Don't think if you said this, you're right, you know. You're not going to get it if you do that, you know. This isn't, I don't see any decimal point in this. So you see, exactly. So the 0.0 there is very necessary now in context. And that's an awesome question. Sound like Chadwick asked the question.
Yes.
Very
sir.
good question, Chad. Very good question. Very good question. All right, guys. So that's how I love it. Ask the question as many as you can. I'm here to answer them. All right, let's move on. Moving along. Moving along. Moving along. I feel like I want to take off this because this is I don't want anybody watching over the recording and think this is an answer. It's not. Okay, that's incorrect. All right, based on the question that was asked. All right, standard form. So you realize that they're repeating these ideas. So I'm writing what it is that we intend to put in standard form. There is a framework for the standard form. 3.6375 times 10. And we're going to raise that to a power depending. Watch. 1, 2. So we jump 2 places. And this is since this number is 300 and something and it's bigger than 1, that means this is positive. So we don't have to do anything. That's the answer. Here we go. Ta-da. That's that. Any question?
Sir, as you did it too right there, so I remember something, but I'm not sure. It just come back when you have like 0. Say for example 0.3250, right, sir? Yeah, from the left to the right, so it'll be negative, right, sir?
All right. So you're saying if you're moving from the left to the right, you'll be negative. You are
Yes.
correct. Let me tell you something. You see, whatever you have that works, keep it. You see, while I'm teaching, I'm going to give what I think works. But you see, you know yourself. So you see, that thing that you have, Chad, left to right is a negative, and then right to left is positive. It works. Understand? The only reason why I introduce ideas over the years is that I've learned that some people don't know left from right. Understand? So sometimes that mixes them up. So yes, man, that you just said can work.
Okay, sir.
All right, good. All right, let's jump on to another question now. Here it is. Let me see if I can. All right, right there, right here. It says Marco is on vacation in the Caribbean. He changes 4,500 Mexican peso, all right, to Eastern Caribbean. He received $600. So listen here. He brought 4,500 pesos come here. And when he changed it out to Eastern Caribbean, he only gets $600. They're saying one Eastern Caribbean is how many Mexican money. You can do this a simple way. I'm going to show you some truth in things that probably people ignore. Watch this. 1, did you know that when you're dividing, it doesn't matter what number you have at the denominator, you know, it's really that you said the number at the denominator into itself, like 640 into itself one time. That's what you really said. Even if you don't do it, that's what you really said. So remember now, the 6 party is EC dollar. Your intention is to have 1 EC dollar. So if you say 6 party into itself, that's 1 EC dollar we're talking.
Sorry, 630.
Yeah, man, me know something. 630. So what I'm explaining here is that you're going to put the EC at the bottom because you're going to say 630 into itself 1 time. And then you say 630 into 4,500 and whatever you get. All right, you'll get something like 71. Let me write it here so first. You'll get 71.4285. We can stop there. Money is a default 2 decimal place, and you don't just write it, you round off. So this is going to become a 3. All right, so you have 71.43. So 1 dege Eastern Caribbean dollar is $71.43 Mexican. Anybody wants to ask anything or wants any clarity on that, please? Please.
Sir.
Yes, I'm listening. Speak, man. Speak. I'm listening.
So me divide 4,500 divided by 630 and me get 7.14.
7. No, man, you never thought something right. Clear a calculator again, Chad. You're ramping up. A second time you do it, Chad.
4500.
Or I mean, huh?
So the same thing I get, sir. 7.
So I mean just something wrong then. All right, good.
Yes,
So I mean then. All right, Chad. So I mean then. All right, so let us fix this. Very good clarity, Chad. Let's fix this. Hold on, guys. Let's put it back. Yes, you're right, because I just look at my calculator. The 0 that I touched did not select. Thank you very much. So it is 7. Let me fix the question. Hold on. Let me take off this. Let me take off this fully. All right, go again, Chad. When you divide it, you get 7.142. 2?
Yes, sir, 2.
All right, good.
It would be 3, Chad.
All right, hold on. Let me divide it. Let me divide it and make sure I see it. All right. Well, I'm all right to write it because a 2 decimal place you're going to have. So watch this. Same principle. So it's 7, my bad. So it is 7.1. So we're saying that money is a default 2DP. So we're going to round off this figure here. So when you look to the right of this is a 2. So that means this remains the same. All right. So thank you for that. So 7.14. Better now?
Yes, sir. That's why I mean I said the 8 because of 2 decimal points.
Yeah, man. You're on the right track, man. Right movements, right everything, right? All right. So 7.14. Anybody want to quickly confirm that? Just confirm it quickly and let us just jump to another question.
Yes, sir. That's it.
All right. Thank you very much. Good looking out, Chad. Continue to look out. Guys, I notice it's 9 marks for these questions. You realize?
So question
9 marks. Question 1 value 9 marks. And you have to work for it. But you can collect all of it because all the questions are kind of wrapped up around a similar idea. Watch again. This is, I think this one was 2019 May. See it there? And you see it? Look, similar. You understand what I mean, you know? Very similar. So let us just do it quickly. We're going to convert everything. We're going to convert. So we're talking about 5, 4s 20 and 1. No, let me write it below because there's a little thing on my screen. So this is 21 over 5 times 1 over 3 minus 4, 1, 4 and 1, 5 over 4. All right. All right. Now, remember though, you can't work out all of these together because this is multiplying and this is minus. So you're going to have to deal with your multiplication. And when you're done, you subtract. So the multiplication part though is here. I'm just going to pull it off so that nobody is confused, right? Nobody. So here, 3 into itself 1 time and 3 into the 21, 7. We always can cancel a number at the top with a number at the bottom when we are actually multiplying. We don't do it when we're adding and so on. All right. So you do it when you're multiplying. All right. If there's nothing else to cancel, then basically it's going to be the top times the top. So 7 times 1, 7. The bottom times the bottom. 5 times 1, 5. So we're left with 7 over 5 right now. But the 7 over 5, let's just finalize. 7 fifths, you're going to minus 5 4.
20.
And then this, yes, 20 is going to be.
20.
All right. So this into that 4, 28. This into this 5. Minus 25. So the answer is 3 over
20, sir.
20.
Very good, very good, very good.
But sir,
Yes.
I wanted a question. So when you say that the multiplication and the subtraction, is that a part of the whole BIM thing or whatever?
All right. Currently, yes. The moment, all right, let me say this to you. The moment you see more than one operation in one sentence, and this is a mathematical sentence, one sentence. So the moment you see more than one, then you start to think about what you just said, your BAMDAS theory. But you still have to understand how the BAMDAS work too. You know, like these two things are on the same level. These two things are on the same level, but these you have to give priority. You know, but you kind of can see. So yes, multiplication comes before subtraction. So you had to multiply. Even if the subtraction was first, for example, let me tell you what I'm saying. Even if, and this is an even, I'm not working on this. What if
And
this?
it comes with the bracket too.
Yeah, man, bracket come first. The B is for bracket. Remember that? So, Chad, what I'm saying, even if this were the case, I'm just making up something. You cannot subtract. No, because multiplication is bigger or is more powerful than subtraction. You get it now? You'd have to get rid of this part first before the subtraction takes place. All right?
Okay, sir.
All right, good. So I'm going to remove it just for a little reference. All right, let's move forward into some more ideas. All right, thank you. So there you could have collected some marks right there. All right, so 4.1 minus 1.25 square all over 0.005. So let's go for it. 4.1. We're going to use our calculator to do this. All right, calculator. All right, hold on, guys. Oh, all right, this is not going back right now. So let me just give it a second. All right, it's gone. All right, so we're going to write back the 1.4 minus, you're going to put together this on your calculator now. 1.25 and you square it. I think 132. Okay, 0.01325. Or it's 1. What you get?
1.5625.
Yes, that sounds like it. Yes. All right, so we're talking about 1.5625, right? And then you subtract that and it's going to be over 0.005. Let's go for the next step. So you just do your subtraction. You could do this now. I'm afraid don't do it in one go, and I'll tell you why. You only do it in one go if you know exactly what you're doing. So watch me. I'm asking you to make sure you get one answer at the top first. Then you do the division. You see, if you're going to put it in one go, you have to put a bracket around this before you insert the division. Your calculator will operate the order of operation if you just line it out here. So in order not to make that error, please get one answer for the top first. Then you just divide it by the answer at the bottom and you're good. So that's just a safety precaution. May I have the answer, please?
507.5.
Thank you very much. Very good. 507.5 is a good look.
And Mr. Edwards,
I'm listening. Go ahead, Mr. Layla.
hey, what if I stop at the 6?
All right, let me bring it down to C. 6. What if you stop at the 6? All right, let this come down. It's not moving. Let's give it a second. All right. You're asking me if you didn't write out everything?
Yeah.
Yes, and stop at the 6.
You're going to get it wrong, sir. You're going to get it wrong. Why would you want to stop? Why would you stop and you got all 4 digits? 5 digits. Why would you stop?
Yeah. Okay.
Never stop. No,
Okay.
you don't do that. You don't round off. If you notice the questions up top, they were asking us to round off at different times. You saw that?
Yes, sir.
Allow them to answer those questions. Listen, is it want me to take this thing serious? When them say give exact answer and stuff like, me write out everything on the calculator. Seriously. So don't just round off. Never do that. Especially when you have some simple stuff like this. This is not something where you're saying, but sir, a 14 digits line off my screen. CXC already know when they're going to ask you to do certain things. So just always write what you get. Please. All right. All right, let's go. All right. This question says, a stadium has a seating capacity of 15,400 seats. Calculate the number of people in the stadium when 75% of the seats are occupied. All right, so definitely we're finding 75% of 15,400. So it's 75 over 100 times 15,400.
11,000. So 11,555.
Thank you very much. 11,550.
Sir,
So
that's what I mean now, sir.
okay, sir. Not bad. But use a calculator at the exam.
No,
Sir?
actually, I mean, I mean.
Sir, it come on the exam what day, that's why.
Exactly.
Okay. That was the question that came. All right. Good. All right. The stadium, how that, Abby? The stadium is to be renovated with new seating arrangement. So we're talking about 20,790 seats now. So it's moving up. All right. After the renovation, what is, see this come back again? Percentage increase.
Just
so
like this.
Yeah, we did one just like this. So it is the increase over original times 100 over 1. All right, so you could see the increase. So we're going to set it up, 20,790. If you subtract, was it 15,400?
Yes, sir.
Put it back over the 15,400 and change it to percentage. Thank you. All right, so give me when you subtract it, what you get, Chad?
So we get 5,390.
Exactly. 5,390. Divide that by 15,400 and then just multiply by 100 and put the answer right here. So.
35, sir.
Yes, so the answer is 35 and make sure you put back your percent. So the seating capacity increased by 35%.
Oh, God.
Good? All right, so watch this question now. It says a neon light flashes 5 times every 10 seconds. Hey, you have to be careful, you know. It says the neon light, you know, watch this, flashes 5 times every 10 seconds. Remember, you know? Not every second, every 10 seconds. So we want to make note of that. Show that the light flashes 43,200 times in one day. All right, what we want to do here, we possibly want to find out how many seconds in a day. If I can find out how many seconds in one day, and if and then I can do so many things. You understand? I can use this. All right, watch this. I can use this 5 times every second to find out how many times per second. You know? This is 5 times every 10 seconds. Look, 5 times, you understand, every 10 seconds. So I can know how many times. All right. So if I divide by 5, I'm going to get 1 flash in 10 seconds. If I divide by 5, I'm going to get 1 flash. So if I divide both sides by 5, like I divide by 5, 1 flash every 2 seconds. You agree? You agree with that? Because if I get 5 in a 10 second, that means I get 1 every 2 seconds. 1, 2 flash, 3, 4 flash, 5, 6 flash, and by you reach 10, you get 5. So basically, I get 1 flash every 2 seconds. See there? That means, remember, these questions can be worked out many ways. I am just suggesting a way to go. So all I'm going to do is seconds in a day. I need to know how many seconds in a day. 24 hours in a day.
1,000.
You understand?
1,200, sir.
All right, hold on there with that, Mr. Smith.
Yes, sir.
All right, sir. So 24 hours in a day, 60 seconds make 1 minute. You understand? 60 minutes make 1 hour. Everybody see that? So you're talking about 60 seconds. I'm just teaching. All right, that's 1 minute. And then 60 minutes again. I'm going to give me 1 hour. And then I'm going to have 24 hours in the one day. All right? So if I multiply these numbers, in other words, then it's going to tell me how many seconds in the one day. So I'm going to multiply 60 times 60 times 24. Because this is 60 times 60. Let me just show you, because I just want, this is 1 hour. This is telling me that is 3,600 seconds in a 1 hour. And then I'm going to multiply 1 hour by 24. And then I get for the entire day. And this is going to be 86,000 something 400 seconds in a day. So this is not the answer though in a chat. This is the amount of seconds in one day. But we want to know, show that the light flashed 43,200 times in that one day. So now you're going to divide. All right? So you're going to divide the 86,400 by the 2. Because remember, every 2 seconds it flash. Every 2 seconds it flash. So it's half of it. And you're going to get 43,200 flashes. Now, this is just one approach. And I can't bother to show many approaches. All right? So this is just one approach, or you could just dissect the problem and walk your way through to there. So Chad, did you go all the way?
Sir, me work it out, Come here, say it look like the whole for multiplication today. So me start multiply. And then me say, say a 2 divided by, but me say me I wait for you first.
But so you get it in the exam, or that may ask, because I think this question was on the paper.
No, that one then no company test.
Oh, so I drop off then. All right.
You want to drop off, man, would I get
That's it. All right. Guys. Why am I telling you? All right. Anyways, it says here that using a calculator, otherwise evaluate each of the following. You notice we're going back to this same thing here, but you see it's under style. So this look, we're going to talk about that. And so this look. So let us rewrite first. All right, we're going to rewrite. So in rewriting our thing, at the top we'll have 4 2s 8 and 1 9 over 4 minus 5 1 5 and 1 3. Oh my bad. 5 1 5 and 3 8 over 5. And this is actually over 3. All right. Let's work out what is at the top first, and then we discuss the other thing after. So at the top, we're talking about 9/4 minus 8/5. 20, Chad, seems to be the number.
Yes, sir.
4 into 20 goes 5, and then 5 9s, that's 45. 5 into 20 goes 4. 4 8s, that's 32. 32 from this, I'm talking about, make sure I'm not making any error. Am I right with 13 over 12?
Yes, sir.
Over 20. 13 over 20. And then now the answer at the top must be divided by the answer at the bottom. But guess what? 3 can be written as 3 over 1. Yeah, so you can feel a little bit more, safer if you're feeling it's because some people love get intimidated. So you probably put it over 1, and then now you change that division to multiplication and reciprocate. So we're going to flip this. What are we looking at? We're looking at 13 over 60. That's it. Good to go?
But sir,
Go ahead.
what if you not do the R word and you just divide it by 3? It are wrong.
And tell me what the answer is.
Let me check.
4.333333.
You're wrong till you're weak. You're wrong till you're wrong till you're buck.
The amount of 3 come 3.
Yeah, it's incorrect. You have to be careful. All right, just be careful. You have to be very careful.
So that's our common sense.
All right. All right. You see again, they're checking you on this now. 2 points. So they want to know that you can do this. Put this on your calculator. Make sure the calculator is in degree. 2.14. So let me go ahead. 2.14 times the sine of 75. 2.14 times the sine of 75. And confirm with me. I'm looking at 2.067081268. But the question now, the question is specific because it says
2.07.
Everybody agree? 2 decimal place. Therefore, let's identify that digit that is in that spot.
670.
And then to the immediate right, you have a number that is in the 5 to 9 category. So that goes up by 1. Right?
Yes, sir.
2.07.
Yes, sir.
Are we correct there?
Yes, sir.
All right, good. All right. So you just have to work your thing and don't get intimidated. Take your time and do what you have to do. All right, so that's that. Let's see what else coming. Hold on, guys. This is dragging a little bit. It's dragging still. All right, let me see if I can reduce the size. A little bit. All right, maybe that. All right. Can we see that? It's clear enough?
Yes, sir.
All right. It says Irma takes home $4,320 per fortnight. Listen, these terminologies are very serious. So fortnight, and they put it every 2 weeks. It didn't say weekly. She's taking home this every 2 weeks. It's not weekly. Each fortnight, Irma pays in and allotted according to the table. All right. Irma's pay is allotted according to the, all right, good. So they are saying, just observe the table and you see how her money is dealt with every fortnight. So for rent, X. Food, $600. For other living expenses, this is 2X. Savings, 1,750. The total, you could see that. So remember now, they're giving her salary in an algebraic thing now. So you're going to have to say they're weaving in algebra in the question 1. What is Irma's annual take-home pay? Assume 52 weeks in a given year. Her take-home pay, you know. Remember, you know, they already told us that she's making $4,320. And I'm just going to say every 2 weeks because I want to reiterate the idea. Every 2 weeks. So if I know how many weeks she's going to be paid for the year, and she's definitely going to be paid 52 divided by 2, which is 26
times it by the 4,000
weeks. So she will be paid 26 times. She will be paid 26 times. So here is the deal. 4,320. She will get that 26 times.
112,320,000.
Thank you very much. So she will be paid 112,320,000. She will be paid that every year. All right. So we have to be careful now. Remember, every year, this is just every year. All right, let's see. I think my thing is moving a little bit shady. Let's give it a time. So it jumps. All right, good. Let's go to the next question. So we're gonna have to come back to that part every time. Make sure you write down them things in the chat. All right, so the next question says, it says, determine the amount of money that Irma allocate for rent. Listen, let me go back up here. So I think we can work this problem up and then write it down as when we're ready. Because since this is so far. All right, you know what? No, I can't. If I had the question on my phone. All right, you see, they want to know how much money she allocated for rent. So if I were you, I'm going to set up a system where all of this money must be added up to give this. So all of this will be on the left side equal to this on the right side. We probably could just work it out here. So, and then we write the answer down there. So they want to know the money allocated for rent. And when I go down there, I'm going to look to see what they really say. Because I don't want to just dash out the answer. Matter of fact, let me look from now what they really say. Because you have to be careful. All right. Hold on. Hold on. Each month, you see that? Determine the amount of money Irma allocate for rent each month. Remember that the money that she got, that you're going to see in the table, is for 2 weeks. That means you're going to have to double whatever you get for 1 month. Everybody agree? Because that's for 2 weeks up there.
Yes,
the table is a
Yes,
2-week table, and we're dealing with a month. And I'm saying to you, this is just as though I was up there and I wasn't certain what I read. But come back, come look. Make sure you look, man. You understand? Because you're not get it right if you write the wrong thing. You can tell you, because that's the reason why they set it. Now, isn't it true that we can say this? X plus 629 plus 2x plus 1,750 is equal to $4,320. All of those things that she has on her expense list added up must come to her total pay. And this is a 2-week thing, we know that. So basically, let us know, work towards, yes, very good. Solving for X. I want to highlight the X's that we have here. All right, so together, X and 2X will give us 3X. And could you just put together, we could start subtracting these if you want to. It's up to you. All right, you know what? I like to put it together one time and do one subtraction. That's just my style. So I'm going to add together 629 plus 1,750. And I'm going to write it just to let the equation flow. 2,379. And all of that is equal to 4,000. Somebody said, sir. Go ahead.
No, it's a yes, sir.
Okay, okay. And at this time, we can subtract 2379 from both sides, leaving the 3x. We're solving for x. $1,941. We're going to divide this by 3. X is equal to 647. This is for 2 weeks. The question wanted for a month, you're going to make sure that you double this. You see the trick? A lot of people are doing this. So for the month, it's going to be $1,294 for the month, because we get the 2 weeks thing here, but they wanted to know for a month. So that's the answer for the month. Clear enough? Talk to me now, man, everybody. Talk to me. Talk up, talk up.
I can't go on, you know.
You can't go on. All right.
May that verify though, sir.
All right. Nothing wrong. Oh, you mean you would have want to put what X here so and then work it out?
Yeah, may that plug them in and see if me get back the total.
All right, but you have to be careful though. You have to plug them back when you get the 647.
Yes, may that multiply by 2 and then may that put it up top 2 and then add up everything and see if we get the total.
Yeah, very good, very good. But at the end of the day though, remember the question though, because you know that a lot of people sending this for the answer. I'm telling you what happened. A lot of people sent in this for the answer. You lose the mark.
Yeah, till I catch me, that's why I'm saying me that verify.
Oh, okay. So you have to be careful. You will lose a mark because you will get some mark. Let me look. If it is 2 marks, you would have gotten 1. Let me look. If a 3, you would have gotten 2. They probably get 2 for all of that thought process and thing. So you would have gotten 2. But definitely the answer was 1, 2, 9, 4, and you call it all 3. So just always aim at your all 3. All right? Everybody, good to go?
Yes, sir.
All right. Let's wrap up this. All right, let's wrap up this. This one says, all of Irma's savings. Let me pull down this a little bit. I put it up. Why not? All of Irma's savings is used, all right, to pay her son's university tuition, 150,000. Irma remains the same, and she saves the same amount each month. All right, so we can work on that. What is the minimum? You hear that? What is the minimum number of years? Minimum number of years that she must work in order to save enough money to cover. All right. So the minimum number of years she's gonna have to work to cover. Let's is anybody having access to the savings up there? I have to go Jack, go back up there.
Sir, 112,000 something. Never write down here.
Nah, man, savings we are talking about, man. I have to read the question.
Oh.
Irma saves. So look at savings now up there. No, just because sometimes this thing hard to jog.
1,750.
Okay. All right. So and that's every 2 weeks, you know, remember that?
Yes, sir.
All right. So to save 1,750 every 2 weeks. So you actually can know how much to save for the year. Agreed?
Multiply that
by 26. Because remember, 26 times it will happen.
Exactly.
So,
Yeah.
so you want to know, the yearly. All right? Yearly, because watch this. Irma, so we're dealing with a year thing, you know. So we want to know how much to save a year. So we're saying now the savings yearly. She save. What you say, 1,750?
Yes, sir.
And you multiply that by 26.
26 or 24.
26. It's 52
Because
weeks,
that's
52 weeks in a year.
I have divided by
And you
Oh.
divide it by 2. Get
Yeah,
it?
45,500.
Yeah, man.
All right. All right. She's saving 45,500
Say I go find out how much
a year. She's saving this per year. And she needs to meet this amount. So you can see that dividing can help you to figure out how many years. Because this is for 1 year. So it's like you're saying 1 year money. Let me see how many years come out.
0.3.
All right, very good. Anybody want to confirm? 3 point.
No, 0.
Nah, man, me get 3 point
No,
something.
it's
Double check.
3.296703297.
Yeah, right.
All right.
Yes, sir.
All right. So approximately we're thinking of this. All right. 3.3 years, basically. All right.